Hi everyone. We're representing Joul-E, the Smart Energy Management System team. My name is James. This is Khushal, Carolyn, and Rutvi. So as you see behind me, these are your standard transmission lines, which are bringing energy from the commercial grid straight into all of our homes. Did you know that 96% of all U.S. energy consumption actually comes from the commercial grid? So what happens if this grid goes down completely, either in the case of a cyber threat or a physical threat, as you can see here, like a hurricane? There's a lot of reasons for this. The grid is vulnerable, outdated, and inflexible. It simply cannot withstand the pressures brought onto it by a physical threat, such as a hurricane, as you can see here. The U.S. Air Force approached this with a specific problem prompt to come up and optimize an energy storage solution in the case of this black sky event. After speaking with many people in the field actually about this specific problem, we had our own twist on the issue, which is we wanted to come up with a specific energy source that can address the black sky event. We addressed several challenges in addressing the specific solution, technological requirements, policy challenges, and financial challenges.
Our main, sorry. Our main sponsor is the US Air Force in association with IBM, and within the Air Force specifically, we have the Office of Energy Assurance. We have the Office of Energy Assurance, and our main point of contact being Sean Bennett. This is what the Air Force base structure looks like, and our main beneficiary would be the energy manager, who is not only responsible for paying the electricity bills, but is also responsible for maintenance of the transmission lines and ensuring that the base has 24/7 uninterrupted power supply. We spoke to Chris Archer, who is the base civil engineer at JBMDL, the Air Force Base in New Jersey, and a few of his everyday functionalities include facilities maintenance, energy management, properties management, construction of new facilities, etc. And related to energy, his main pain points were that he wasn't able to control the supply of power to critical and non-critical usage, and also if the power did go out for a long period of time, they had energy for just 7 days. And out of this project, we aim to overcome these two deficiencies that he had and provide him with an ability where he can manage his supply into critical and non-critical loads, as well as if the power does go out for a long period of time, provide him with a resilient energy solution that can last him for a longer period of time.
So currently, the United States Air Force, like most utilities or facilities across the United States, is dependent on the commercial grid as their primary source of power. But as James mentioned, that commercial grid is extremely vulnerable, and it can go down for anything as minor as a small technical malfunction to something much more severe, such as a large-scale cyber attack or even a natural disaster. And currently, if that grid does go down, the Air Force relies upon their diesel generators to provide backup power for their critical loads or their critical functions. And these are functions that are defined as, having critical abilities, such as hospitals. These diesel generators last for a maximum of 7 days, and they are prelude by some sort of small battery, which lasts for approximately 5 minutes, just enough time for those larger diesel backup generators to get up and running. But the concern is, what happens if there's some sort of black sky event? And this is defined as some sort of catastrophic event that causes the grid to go down for an extended period of time, even forever. And so that's where Joul-E comes in. If that grid ever goes down, Joul-E would be able to replace that commercial grid and provide direct power to critical functions. If the grid, however, is working in a normal scenario as it is today, Joul-E would still be able to work, and it would provide a supplementary power source, so it would function in parallel with the current commercial grid. So to clarify, our vision is to move away from the centralized grid into more localized power generation. To further break this down, we envision multiple different power technologies, such as power generation or power storage technologies, that would all feed into an energy management system, which is essentially what Joul-E is. Joul-E would be able to take all of these different inputs and enable a user greater control over these inputs and help them decide how to best allocate this power into critical and non-critical loads. Here we have a textual representation of that previous diagram with some examples of current technologies and hardwares that are already on the market, very generally, for example, solar and wind generation, lithium-ion batteries for storage. The main takeaway here is that Joul-E is a software, which means that it can integrate with hardware that is already on the market, as well as technologies that are still in the development phase, so it'd be able to adapt for future applications. When there is a black sky event, Joul-E would be able to take current EMS systems a step further by offering functionalities that customers who we interviewed said that they were interested in, but don't currently have access to using current things that are on the market. For example, predictive energy forecasting, among other utilities that we'll speak to more later on. When the grid is working, Joul-E will essentially pay for itself through energy savings or energy sellback methods. This software would be coupled with some form of consulting service to help a user best decide how to design a resilient energy solution, taking into account their individual needs as well as their geographical location. And Rutvi will speak to that now.
To create an optimizing model for Joul-E, we decided to have two main criteria, the regional market and the geographic location. So for regional market, we focused on SPP, which is Southwest Power Pool, which caters to 14 different states in this country. For our specific geographic location, we looked into cross-referencing the regional market with the number of Air Force bases they have. Oklahoma has 3 Air Force bases and is completely catered by SPP. So we decided to focus on Oklahoma for our case sample. Our solution was validated by the third party, which is EDF in our case. And the solution was based on Homer, which is a microgrid optimizing model or software that is used by energy professionals in this industry. To understand the island mode, we compared 2 different scenarios, which is 2 different geographic locations, that is Oklahoma and California. Joul-E comes as a consulting here where they can decide what different types of microgrid components are present. As you can see, Oklahoma has solar and wind, whereas California just has solar, giving us 2 different net present cost. This is the case when there is an island mode. What if this is not an island mode like today, and the grid has to pay back? So this is a case where we took in net metering cost. A net metering is a type of policy in which excess energy can be sold back to the grid, thus giving us a net present cost of about 5.39 million and a simple payback period of over 11 years.
So now moving into our Joul-E business plan, as mentioned previously, retail sales make up 96% of this market for U.S. energy consumption in total. We further broke this down to 3 main sectors: residential, commercial, and industrial, totaling 38, 37, and 25% respectively. So we chose to focus in on commercial for several reasons. One, there's high potential and there's medium to low risk associated with it. By commercial, I specifically mean things like hospitals, college campuses, corporate governmental institutions. So we looked further into the potentials and challenges associated with this commercial sector. We found that that the critical needs of these specific institutions in the commercial sector are pretty high. They're going to want to implement a system like our EMS as soon as possible. Additionally, it makes up a pretty large percentage of the market at 37%, as you can see up there. Additionally, people are going to be willing in these institutions to implement our technology as soon as possible and actually pay a good amount of money for it, since they have these critical needs that have to be addressed as soon as possible. As far as the challenges go, we anticipate that it will take a good amount of time before we see revenue and actually get the system up and running. However, as Carolyn mentioned previously, the next best thing that they have right now is a week of backup power. So there's very little risk associated with actually implementing our EMS system. So as far as commercial goes, we want to go into hospitals and college campuses. In hospitals, obviously, you're going to have patients who are on life-saving devices, which have to go for 24/7. College campuses, you're going to have research facilities, which also have to go 24/7. We do foresee, however, in the future, markets in communities and office buildings, but for right now, we think the most imminent need is in the hospitals and college campuses. So.
We do acknowledge the fact that we already have quite a few competitors out there in the market who provide an energy management system. But we conducted a competitor analysis, and we found that most of these companies lack a few major features that the customers want. Them being predictive energy generation, the ability to supply power to critical and non-critical loads, as well as the ability to work under a grid mode or independently in an island mode. And this is what is going to differentiate Joul-E from the other smart EMSs out there in the market, because Joul-E is going to provide these features which are wanted by the customer and validated by them and is not currently available to them. The 2 main components of Joul-E are the software and the hardware. The software will be the heart and soul of the system, which will be developed in-house and which will have a proprietary algorithm, while the hardware will be developed in association with a key partner and will be used to communicate with the facilities on site. A few of our key partners include third-party energy suppliers, microgrid vendors, utility services, as well as other energy management systems, provided that they do not compete us and try to bring out a similar product into the market. We spoke to the facilities manager here at Johns Hopkins, and we found out that Hopkins actually wants a system such as this, and they're actually willing to pay for it because they have quite a few critical facilities that need power 24/7. And we can use this validation and this first case scenario to leverage our way into the other institutions out there and grow and grow exponentially.
So there are 4 key stages in actually developing Joul-E. The first 2 are focused on developing that software, and the last 2 are focused on integrating it with hardware. Given that our immediate focus is really on stage 1, which is a software prototype, we further broke this stage down into 6 key steps. So the first few steps of that is really focused on refining the idea, defining what Joul-E is, analyzing again customer needs, and conducting a patent search. This would then move into the development phase, which is really the key part of stage 1, where we'll develop an initial prototype for hardware testing and integration testing. And this will lead us into the testing and maintenance phase, where we'll begin identifying and negotiating key partners to start linking together the hardware and the software components. We think that we can conduct this on the Hopkins campus because of 2 reasons. The first being that David Ashwood, the facilities manager here, has expressed interest in purchasing a system similar to this. And the second being that there are many faculty members here who have extensive expertise in this field.
We looked into the financials. While speaking to David Ashwood, who's the director of facilities at Hopkins, we found that these are the amount that they're ready to pay for different components, which is software, hardware, and maintenance. This sums up to giving Joul-E an energy gross unit of about $152,000 to $252,000 per unit. Finally, if the Joul-E has to play an integral part within the Hopkins facilities, Hopkins already has certain hardware that they have already implanted for the couple of years. Joul-E just comes into as a software, which an algorithm, which is developed by our research team, which will just integrate the software and the hardware that is already placed. Our initial target consumers will be, as James said, that universities with endowments greater than $1 billion in our research focus, which are about 50 in the United States, and for investor or investor-owned or for-profit hospitals, which are about 1,035. In the first year, we will be focusing only on university campuses, Johns Hopkins, but starting with Johns Hopkins. In year 2, we would be moving towards for-profit hospitals and university campuses. And in the final year, we would venture into a completely different market, which is industrial and residential. For our future works, for the product development, we would require building the algorithm and also making sure that it integrates with the original hardware that is present. And for our Air Force, we would require the Air Force people to understand what the difference is between critical and non-critical loads, as it is an important part of the Joul-E system, and also to open tender for our hardware and software systems.
This is our very talented team of engineers here at Hopkins who is going to bring Joul-E to the market and be really successful as a smart EMS system. We want to thank so many people over this last semester who helped us out tremendously, Professors Ehrenheim and Devura, and our sponsor, Sean Bennett, who could not be here today, but we will be giving him the same presentation on Monday at his office. So thanks so much, and we'll be happy to answer any questions.
Interview you had with the facilities manager here at Hopkins, but what else did you do to test the viability of the market?
So, do we need this? Okay. It's for recording. So we talked to both the facilities manager here at the campus. We talked to the facilities manager at the hospital. There are 2 separate ones. We also spoke to EDF, which is a third-party energy company that the Air Force is currently working with, and we've run this by Sean Bennett, our sponsor, as well.
So I think you did a good job finding who has the pain, at least on the Air Force side, the base energy manager, and I liked how you broke out what the pains were, including control and resilience. But it's intuitive to me how Joul-E would solve the control issue, but how would it solve resilience? It seems like it would still require someone to purchase panels or turbines. So how does your solution solve resilience?
I can answer. Okay, so the key defining component is the fact that it can run in both grid as well as island mode. So as people are developing systems with greater resiliency, the idea is to develop sort of a microgrid, which is a localized generation system. But it's not enough. Like, you're going to need all of the components. It's not enough to just have generation or just have batteries, which is why we had to shift away from that initial problem prompt, which is so focused on battery storage. Because after talking to users, it was very apparent that you can't just have one component. You need this entire system. And the key defining part of Joul-E is that it is the control panel for all of these different components. And the fact that it can function in island mode means that even if the commercial grid is down, it will still be useful, unlike other EMS systems that are reliant on the grid.
I'll just add to that. So yeah, so it does require that the user actually does have like certain capabilities as far as storage and generation goes. Like, that's not going to be our business per se. It's like they on their end should actually have some sort of generation in place, like that is I guess, supplementary to like what will last them for at least that week, as we were mentioning previously. So right now it's just like diesel pretty much, but there will be some necessary component if they want to go 35, 40 days or more as far on their end. But our control, like our control system, is going to best optimize whatever they have currently to help them get them through whatever outage they're experiencing. Yeah.
I guess as the executive director of our information security institute here on campus, I should add that this system that you're proposing should have security properties so that it's not the object of an attack if someone wants to take down the grid. So make sure you include that in your desirable properties.
And I would just add one other beneficiary that you may want to consider is this idea of a consultancy, right? I mean, I could easily see where there'd be lots of corporate customers or even industries that want to do an assessment of what kind of investment would be required over time to be able to get to this idea of island operations versus, what's that total outlay? And then the benefit.
So Joul-E is actually like, it's a part of the entire product, and that is a main selling point. Like that will be a product that will be selling, but along with Joul-E, we also intend to have consultancy services that tells the customer as to what kinds of generation and storage capacities it needs, and then how to couple it with Joul-E and provide an entire microgrid solution.
Have you all looked into the way solar panels are subsidized and particularly the PPAs, the power purchase agreements? I learned this as a new homeowner, and the reason why I bring it up is because my house is set through BG&E locally to operate as an island, but I had to specifically get a lawyer involved to do this. As a normal Vivint or Solar City customer locked into a 20-year contract for a PPA, they don't come out and say, hey, power goes out in the area, you can keep your own power because you're still generating from the solar. I had to go through the wickets and figure that out on my own. The other point I bring up is on the commercial side, looking into LEED certifications for buildings. That's going to be a major opportunity to find new potential customers.
Thank you so much for the input. We looked into the solar subsidies, and it's basically based on geographic locations. So it will come into consideration if Joul-E comes into play, where they would consider if there's any other subsidies, not just solar, being wind also, and it would implement that when the cash flows that we make for them.
So great job again, and then in particular, just to echo what Joe said, nice job just narrowing down who actually had the pain within the Air Force. Did you have the chance to iterate with the base civil engineer at all in terms of your potential solution and whether they were addressing the pains and potential gains?
We reached out multiple times and eventually ran out of time, but we never got a response after that first point.
Initially, he had actually mentioned something about an microgrid and them being working on it. So the base already has they're working on a solar PPA agreement, and they were also interested in a microgrid. So we did not get to actually verify the final product, but somewhere in the middle of the semester, we had actually reached out to him, and he validated what we are saying and what we have actually come up with.
All right, thanks everyone.